Brand new topic. This topic is matrices, and this word is plural of the word matrix. Two or more matrices, well, the plural of matrix is matrices. And a matrix is a table of values made up of horizontal rows and vertical columns. So when we talk about rows in a matrix, we're always talking about horizontal. When we talk about vertical in a matrix, we're always talking about columns. So here is row 1, and here is row 2. The rows are horizontal. Let's look at the same matrix but let's focus on the columns. This is column 1. This is column 2. And this is column 3. Each number in a matrix is called an entry. The number 2 is an entry or an element of the matrix. The number 3 is an entry or an element of the matrix. The number 4 is an entry or an element of the matrix, and so on. And typically we use capital letters to represent matrices symbolically. So we call this matrix the capital letter A. The size of a matrix doesn't directly give us the number of elements. Indirectly it does. But the size of a matrix actually tells us the number of rows and the number of columns. See, the rows are horizontal, so how many rows does this matrix have? 2, right? The columns are vertical, so it has 1, 2, 3 columns. So the size of this matrix is 2 by 3. Number of rows by number of columns. And the convention is always rows first, columns second. Let's look at a few more examples. Let's take a look at the matrix B here. We have 3 horizontal rows and 2 columns. So the size is rows first, 3 by 2. That's the size. One of the reasons that we care about the size of a matrix, number of rows times number of columns, is that matrices of the same size can be added and subtracted. Matrices of different size cannot be added or subtracted. So let's look at matrix A and matrix B. And we're told to compute A plus B. Well, A, 2 rows, 3 columns. B, 2 rows, 4 columns. They're of different size. They can't be added. So our response is impossible. The matrices are not the same size. And in case you're wondering, this is not a temporary situation that can be remedied. It's not going to be the case that, well, when we really get to know this stuff, we'll learn how to add and subtract matrices of different sizes. No, that's never, ever going to happen. So it's no matter how good we are at math, matrices of different sizes cannot be added and subtracted. It's not the case where we're going to learn how to add and subtract matrices of different sizes. Nope, that'll never happen. Now, let's see how we add and subtract matrices that are the same size. These two matrices are the same size. They're both 2 by 3. So they can be added. To add two matrices, we add elements in like position. So in other words, the element 1 is in the first row in the first column. And so we take the element in the first row in the first column of B and we add them together. The element 2 is in the first row in the second column. So to it, we'll add the element from B that's in the first row in the second column, and that's 3. The element 3 is in the first row in the third column. So we take the element in the first row in the third column of B and add those together. And then we go down to the second row. 4 is in the second row, first column. So we take the corresponding element of matrix B. 2 is in the first row, the second row, first column. Second row, first column, second row, first column. We add these two together. 5 is in the second row, second column. So we take the element in B that's in the second row and second column. And then finally, 6 is in the second row and third column. And we take the element from B that's in the second row and third column, which is also 6. And when we simplify this, what do we get? So this is our answer. This is A plus B. Now, how would we subtract one matrix from another? subtract B from A, and that is compute A minus B we subtract elements in like position. So let's try this one out. A minus B to subtract B from A, we'll go to the element in A, first row, first column, and we'll find the corresponding element in B, first row and first column. And we'll subtract the element in B from the element in A, 1 minus 1. Then we'll move to the first row, second column, and we'll find the element in B, first row, second column. We'll subtract the element from B from the element in A. Then we go to the first row, third column, and find the corresponding element in B, first row, third column. We subtract the corresponding element in B from the element in A. And go to the second row. We're in the second row, first column. So we find the corresponding element in B, second row, first column. And we subtract the corresponding element in B from the element in A, 4 minus 2. Then we move to the second row, second column in both matrices and subtract the corresponding element from B from the element in A. And then we go to the second row, third column and find the corresponding element in B, second row, third column. And we subtract the element in B from the corresponding element in A. And so here we have it. This matrix, A minus B. Let's see, what else can we do with matrices? We can multiply a matrix by a real number. Okay, multiplying a matrix by a real number. To multiply a matrix by a real number, we multiply every entry of the matrix by that real number. For example, we have the matrix A. It's a 2 by 3. 2 rows, 3 columns, a 2 by 3 matrix. We're going to multiply it by the real number 3. So this is 3 times A, and we write it this way. And we actually take each element in the matrix and multiply it by 3. So 3 times 2 is 6, 3 times 6 is 18, 3 times 9 is 27, 3 times 5 is 15, 3 times 4 is 12, 3 times 7 is 21, and this is it. This is 3 times A. We're going to learn how to multiply two matrices together, but before we can do that, what we need to learn how to do is multiply a row by a column. And we can only do this if the row and the column have the same number of elements. So let's look at something that we can't do. Here's our row, and here's our column. The row has 3 elements, the column has 4 elements. We can't do this. So we can't do this. This row has 3 elements, the column has 4 elements. We can't do it. We can only multiply a row by a column when they have the same number of elements. And note also the row is always on the left and the column is always on the right. So let's try this again with something that we can do. We have the row on the left, the column on the right, that's good. And they both have the same number of elements. And what we decided was we multiply first element by first element, second element by second element, and so forth. And then we add everything up. So let's see. First element by first element. Okay, first element by first element. Then second element by second element. So 3 times 6. Then third element by third element. 1 by 5. And then finally, fourth element by fourth element, 4 times 2. And we get 8 plus 12 is 20, plus 5 is 25, plus 8 is 33. So this is kind of interesting. We multiply a row by a column, and we get a single number. We don't get a matrix, we just get a single number. Try another one. This row has 3 elements. This column has 3 elements. So we can multiply them together. And the way we do it, we take the first element of each and multiply them together. 1 times 10. we take the second element of each and multiply them together. And we take the third element of each and multiply them together. -14 is -4, plus 30 is 26. Okay, there we go. Now, the reason that we wanted to look at the product of a row and a column, and I should mention this also. The row is to the left. Here's the row, and here's the column. The row is to the left of the column. The reason that we're looking at the product of a row and a column is because it is possible to take two matrices and multiply them together if it turns out that they are the right size. And this is what we're going to look at next. The product of two matrices. The product of two matrices can be computed provided that the matrices are the right size. And our initial guess is, oh, okay, the two matrices have to be the same size. And that's the case if we're adding or subtracting matrices. If we're adding or subtracting matrices, they have to be the same size. But if we're computing the product of two matrices, that's not true. They have to be the right size in the sense that the number of columns of the first matrix has to equal the number of rows of the second. Now here's a matrix A, and the size is m by n. M rows, n columns. Here's another matrix B. Its size is n by r. N rows, r columns. This product can be computed because the number of columns of the first is equal to the number of rows of the second. So before we multiply matrices together, we're going to look at some possibilities and just discuss whether the product can or cannot be computed based on the sizes of the matrices involved. Okay, here are some pairs of matrices, and we'd like to look at each pair in the order that they're given and just determine which products can be computed and which can't. Now, the matrices don't have to be the same size, but they do have to be the right size with respect to one another. And the rule of thumb is the number of columns of the first has to be the same as the number of rows of the second. This is a 2-row, 3-column matrix, so 2 by 3. And this has 3 rows and 2 columns, so it's 3 by 2. And the product can be computed if these two things are the same. So here, that product can be computed because the number of columns of the first is the same as the number of rows of the second. Now let's go to the second pair of matrices and let's see if they are of the right size with respect to one another. This has 2 rows and 3 columns, so its size is 2 by 3. And this has 2 rows and 3 columns, so its size is 2 by 3. Uh-oh. These two things are different, so the product can't be computed. This product is not defined because the number of columns of the first is not the same as the number of rows of the second. Okay, let's go to this product. This one has 2 rows, 2 columns, so it's a 2 by 2 size matrix. This matrix has 2 rows, 2 columns, so it's also a 2 by 2 size matrix. And the important thing is that the number of columns of the first and the number of rows of the second are the same. And they are. Since this number and this number are the same, the product can be computed. Okay, let's look at this pair. This has 1, 2, 3, 4 rows and 1, 2 columns. So this is a 4 by 2 matrix. And this matrix has 2 rows, 1, 2, and 3 columns. So this is a 2 by 3 matrix. And guess what? The number of columns of the first and the number of rows of the second are the same. So yes, this product can be computed. And then finally, this matrix has 4 rows and just 1 column. It's a 4 by 1 matrix. This matrix has 2 rows and 4 columns. Can we compute the product of these two? You know, we can't, because these two numbers are not the same. So no, this product can't be computed. And maybe there is one other thing that I should say about the product of 2 matrices, but I'm going to have to give myself some board space before I make the comment. Before we actually compute products of matrices, I want to comment about what we get when we multiply 2 matrices together. And first of all, to multiply them together, the number of columns of the first has to equal the number of rows of the second. So we're assuming that these two are equal. And when we multiply the 2 matrices together, we get another matrix that has the number of rows of the first times the number of columns of the second. So the number of rows of the first times the number of columns of the second. So before we multiply two matrices together, we should check to make sure that the number of columns of the first and the number of rows of the second are equal. And then we should also remind ourselves of the size of the product of the matrix that we expect to get. We expect to get a matrix that has m rows and r columns. So, that having been said, I will explain how to multiply two matrices together. Okay, we're back. I have a 2 by 2 matrix times a 2 by 2 matrix. These two numbers are the same, so I know I can multiply the two together. And I'm going to get a matrix that has 2 rows and 2 columns. So what goes here in the first row and in the first column of my product? And keep in mind, I'm in the first row, first column. This is the product of the first row times the first column. First row times first column. And I'm going to need some more room, I guess. Okay. Now, I go down one entry. I'm still in the first row. No, I'm in the second row now, but I'm still in the first column. I'm in the second row, but I'm in the first column. So to get this entry, I take the second row times the first column. Second row times first column. Well, that takes care of the first column here. Now, first row, second column. I'm in the first row and the second column. To get this entry, I multiply the first row times the second column. First row, second column. And I go to this entry. I'm in the second row and the second column. To get the entry that should be in the second row and the second column, I take the second row times the second column. Okay. Now let's actually crank this thing out. This entry is supposed to be first row times first column. This row times this column. We can do that. It's going to be the first element, the product of the first elements, 2 times 6. Plus the product of the second elements, 3 times 3. Well, that was easy enough. Now let's do this one. Second row times first column. Second row times first column. So we take the first element of each, 4 times 6, plus the second element of each, 5 times 3, well, we finished that. Now we need to go to the second column. This is first row, second column. So it's the product of the first row times the second column. And we take the first element of each, 2 times 2, times the second element of each, 2 times 1, we have one more entry. Second row, second column. It's the product of the second row of the first matrix times the second column of the second. And we take first element times first element, 4 times 2, plus second element times second element, 5 times 1. And what does this turn out to be? 12 plus 9 is 21. 24 plus 15 is 39. 4 plus 2 is 6. And 8 plus 5 is 13. So this is our product. Let's do a few more. Okay, another one. This is a 2 by 3 times a 3 by 2. These two numbers are the same, so the product is defined. And we expect to get a matrix that has 2 rows and 2 columns. So this matrix should be 2 by 2. Let's start right here. The first row and the first column. How do we get it? We take the first row times the first column. And we take the product of the first two elements, 1 times 4. And then we take the product of the second elements, 2 times 2. And then we take the product of the third elements, 3 times 0. This is the entry in the first row and first column. Now let's go to the second row. Second row, still the first column. So we're going to take the second row times the first column, and we'll take the first entries of each, 4 times 4, plus the product of the second entries, 5 times 2, plus the product of the third entries, 6 times 0. So we've got first row, first column, second row, first column. Now we want to go first row, second column. First row, second column. So we take the product of the first row times the second column. And we'll take the first element of each, 1 times 1, plus the product of the second elements, 2 times 3, plus the product of the third elements, 3 times 5. Now let's go down here. We want the second row and the second column. And to get the entry in the second row and the second column, we take the second row of the first times the second column of the second. And we'll take the product of the first two entries, 4 times 1, plus the product of the second entries, 5 times 3, and the product of the third entries, 6 times 5. So what do we have? 4 plus 4 is 8. 16 plus 10 is 26. 1 plus 6 is 7, plus 15 is 22. 4 plus 15 is 19, plus 30 is 49. And this is the product of the two matrices.